So, welcome to this webinar about the use of Myantech wearable EMG technology and application in elite sport. This is going to be a very brief overview, general overview about how to use and how to apply Myantech EMG technology in a real uh, elite sports application, both for individual and for team sport. As you may probably already know, uh, this is just a quick introduction about me. I am a sport performance consultant and strength and conditioning coach from Italy, working worldwide since more than 16 years, uh, both with individual and team sports, in semi-professional, professional, and Olympic level. I started using technology in sports since more than 10 years, and EMG as well, uh, starting from the classic EMG sensor technology and until the implementation now of these exciting wearable technologies, which is going to represent a game changer, especially for on-field sports application. Uh, let's start by defining what is EMG. EMG stands for electromyography, and it is a method for measuring muscle electrical activity occurring during muscle contraction and relaxation cycles. Uh, it is a non-invasive technique, and we can define it as a biomedical signal, which is a this is a quote from a study, a review study from Reyes, Hussein, and Moriazi. Uh, they define EMG as a collective electrical signal acquired from any organ that represents a physical variable of interest. The EMG signal is a function of time, and it can be described in relation to three main variables: amplitude, frequency, and phase. Uh, in the slide, you can see uh, the raw signal of the EMG. The raw signal has one uh, horizontal axis in which you can see time, and a vertical axis in which you can see the amplitude in microvolts, both positive and negative, around the axis which centers on zero. The, uh, the how the EMG signal is generated and detected. You just know that to innervate a muscle fiber, uh, there is an electrical signal that from the central nervous system must reach an alpha motor neuron. And this alpha motor neuron are the neurons that are responsible for initiating muscle contractions. Uh, as the contraction, the signal of the contraction spreads from the alpha motor neuron across the muscle fiber, we will see a series of processes, both electrophysiological and electrochemical, and all these processes are going to produce an electrically measurable depolarization and repolarization, uh, which is known as the action potential. And this is the EMG signal, the EMG looks at this action potential from a number of innervated muscle fibers located near the electrodes. And In the electromyographic signal, all these action potentials from all the different muscle fibers appear together all on top of each other. So, uh, the signal processing of the raw EMG signal can be uh, shown as a can be rectified through a technique used in statistics, which is the RMS, the root mean square. Uh, Here you can see on two type of signals, the raw signals and rectified signal. The rectified, the RMS, is a rectified graph representing the mean power of the signal. This is a technique for rectifying the signal and converting into an amplitude envelope, which is going to make it easier to view and analyze, especially uh, for on-field practical application. We can even adjust the level of smoothing in the RMS uh, processing for the signal. Uh, Another type of signal processing is the frequency domain processing. We can convert the raw signal into the frequency domain by applying an fast Fourier transform calculation, which is a mathematical calculation able to isolate each frequency band, because as you know, the signal, the EMG signal, is comprised of many electrical filings. These filings occur each one at different rates, and the overall signal in the time domain is a composite of these multiple frequencies. So, uh, by applying a fast Fourier transformation, we can isolate each of these frequency bands. And normally, uh, it has been shown both by research and literature that the relevant EMG frequencies are between 20 and 500 Hz. So, with the fast Fourier transformation, we can display and represent the signal in its frequency domain by separating out each individual frequencies. Uh, let's look at how we can analyze EMG signal. Before looking at the EMG analysis, I want to show you and explain you this slide, this image, this picture, which is going to be one of the most important picture that I used to show to my students in all my lectures about technology application in sport. This is why today, when applying technology in a sport, in a team sport environment, we need to follow three fundamental steps. As you can see from the picture, the first step is collecting data. But data, when collected, are only a group of raw signals and raw data, raw numbers, and they are shown here in the picture as a black and gray dots. The second step is to transform this data into information. And you can see that these black and gray dots are becoming colored. We can, let's say, transform this data into information by uh, converting the numbers into by associating this number into a performance indicator, a performance variable. The last step is to transform this information into knowledge. And as you can see from the picture, the the dots are being connected between them. So connecting the dots allow us to solve the problems of understanding performance limitations and weaknesses. This is important because sometimes today in elite sports there is what I call big data overuse, collecting data over data, but without any type of knowledge on how to apply and how to use this data to really improve performance or really prevent injuries and so on. Regarding EMG analysis, the electromyography signals can be viewed and analyzed in three different dimensions: the amplitude, the temporal analysis, and the spectral analysis, frequency analysis. These are the three main important type of analysis that we can do with an EMG signal. With the amplitude analysis, we can check for the activation level of a muscle, and we can use it, let's say, for biofeedback training. With the temporal analysis, we can look at the onset time or activation time of a muscle. So the time it takes for the muscle to contract. And with the spectral frequency analysis, we can look at the mean and median frequencies, and it has been shown by research that the rate of decrease in mean and median frequencies are a good indicator of muscle fatigue. Traditional applications of EMG technology are related to sports science, biomechanics, neurology, and psychophysiology, mainly in a research laboratory setting. And in physiotherapy, rehabilitation, and orthopedics, mainly in a clinical setting uh, for rehabilitation and sports medicine purposes. But the traditional limitations of the EMG application in sport are related to the hardware setup, skin preparation, and software setup. So this is the reason why EMG has not been uh, widely used in a team sports because of the lack of time necessary to set up hardware, prepare skin, and analyze the data. You know that a technology to be considered useful in a team sports should be very quick, very fast, and very easy to apply because of the very little time available in a team setting, and because of the time under pressure that you have in a team environment. Uh, let's start introducing the wearable textile EMG Myotech and body. The Myotech and body are have the EMG sensors that are embedded into the textile, and muscle activity is collected at a sampling frequency of 1000 Hz. The raw signal is rectified and downsampled to an output frequency of 25 Hz into the M cell unit, which is the receiver. The The Myotech body is paired with the muscle monitor software, which is the professional software uh, that can allow us to go through a deep analysis of the muscle electrical activity. The muscle monitor software has different type of view, different windows, and into this screen you can see that we have the muscle load overview, where an average 1 hertz values from muscle load is calculated from the sum of all channels. There is the signals windows, the results windows, and the problem detection windows. This is the muscle load overview. This is an example of the balance graph and the relaxation index into the graph. This is the signals windows where you can see each isolated with each individual muscle, left quadriceps, right quadriceps, left hamstrings, right hamstrings, left glutes, and right glutes. And you can check the overall view to data provided by the MCell for each channel. This is the problem detection uh, window, which is divided in other sub-windows, the distribution, in which you can check for the overall distribution of each muscle group in percentage, the balance between left and right side, the ratio between quadriceps and hamstrings, the muscle group balance, which you can see the balance in percentage between each muscle group, uh, quadriceps, hamstrings, and glutes, and the relax windows, in which you can see the level, you can analyze the level of relaxation uh, in terms of microvolt of a muscle. Uh, what is the application in team sports based on our experience and experience by working with football, basketball, and rugby team? You can use the Myotech wearable technology uh, mainly for testing and monitoring. The testing process is comprised of the screening in preseason and the testing for strength and power, speed and acceleration, and for injury risk and prevention. The monitoring process uh, has a component as an initial component, uh, which is the creation of an individual baseline level for each player in order to analyze neuromuscular efficiency and fatigue, the energy and metabolic cost of training, and injury risk. By creating a baseline level in muscle activation for each player, you can look at deviation from the baseline during the season. What to do in preseason with the Myotech technology? In precision, the process of screening involves two types of, of analysis, a general neuromuscular profiling and a specific neuromuscular profiling. With the general neuromuscular profiling, we are going to assess the movement proficiency by looking at gait testing and at baseline muscle activation testing. Uh, why it is important to measure gait? Because Gait is important because it is the most fundamental movement pattern. Before squatting, before lunging, before jumping, walking is the most important of the basic movement patterns. We normally check a gait task of 30 seconds to look at the synchronization and activation of the lower limb muscles. And with the baseline muscle activation testing, we are looking at the muscle activation of the hamstrings, glute, and quadriceps during functional tasks. With the specific neuromuscular profiling, we're going to assess strength and speed by uh, looking at back squat and, let's say, Romanian deadlift for strength and to check activation of muscle during strength exercises. And for speed, we are looking at acceleration, change of the direction, and repeated sprint ability by testing this uh, skills and performance indicators by wearing the Myotech shorts in order to identify weaknesses and asymmetry during specific uh, task. Uh, so let's say, to recap in precision, we look at gait and baseline muscle activation testing for movement proficiency, and uh, a back squat and Romanian deadlift for strength, and acceleration, change of direction, and repeated sprint ability for speed as a specific neuromuscular profile. This is an example of two testing with a back squat of 10 reps at 60 kilo from two uh, players with the same strength levels, and you can see that they have different type of uh, muscular activation during the back squat. The first player has very low activation of hamstrings and glutes muscle, while the second player has a very high asymmetries in activation between left and right hamstrings, and a very low level of activation of uh, quadricep muscles. And this can be helpful to help you address training and individualized load, and looking at technique of execution to improve the neuromuscular proficiency and activation. This is the same, these are the two same players um, with the problem detection screen. You can see that the second player has a problem with the hamstring activation. During the season, you can use uh, Myotech Embody as a regular training monitoring tool. Uh, this is a very interesting quote from Blake and Wakeling. They stated that EMG contains important information about the metabolic costs of muscle contractions and provides good predictions of metabolic changes during non-steady state conditions. So, one of the most exciting features of the Myotech application is that of analyzing the energy and metabolic cost of training and quantify training load. Maybe this is something uh, that needs to be that needs to be uh, explored and investigate further the possibility to use Myotech and Body together with GPS and integrate the data to deeper analyze and quantification of the training load. Uh, let's pick up some practical examples. Uh, one of the most interesting, uh, one of the most interesting tests and application of Myotech and Body is for hamstring monitoring. Hamstring monitoring through the counter movement jump. The counter movement jump for hamstring monitoring has been popularized by Hank Kryanoff in the late 90s as a very, very interesting tool for monitoring and detection of problems into the hamstring function. By looking at the activation of the activation and the relationship between quadriceps and hamstrings activation during the takeoff phase of a counter movement jump, we can easily identify problems in hamstring. Uh, this is why this is why uh, mm, normally uh, during a takeoff in a counter movement jump, you should see higher uh, activation of the hamstring muscle respect to the quadriceps muscle. Uh, so, as popularized by Hank Kryanoff, the counter movement jump testing for hamstring monitoring uh, has been used for detecting of uh, problems into the hamstring function. Uh, by looking at the activity of quadriceps and hamstrings during the takeoff phase of the counter-movement jump, we can easily identify problems in the hamstring function. So normally during the takeoff for a counter-movement jump, you should see a dominant quadriceps activity with respect to the hamstrings. If you, like you can see into the picture, this is the first two are the left quadriceps and right quadriceps, and the last two are left hamstrings and right hamstrings. Uh, if if you see a dominant hamstring activity during takeoff with respect to quadriceps, this can be a sign of hamstring problems because when active is more active during the takeoff, um, uh, as explained by Hank Kryanoff, it is because it is because the hamstrings tends to slow down or control the fast knee extension because the fast knee extension may cause problems and injury to the hamstring, to the injury-prone hamstring. So this is a very, very simple and fast protocol to be used, especially in team sports with the myotech and body because the protocol is very, very simple. Uh, it, it is enough to perform 3 repetitions of a counter movement jump. You don't need any type of skin preparation and hardware set up. You just need to put on the shorts and jump. So it is easy to use on a weekly basis to monitor hamstring function and help in preventing injury and strains of the muscle. Another example of testing is for baseline muscle activation is by looking at the hamstrings and glutes activation during the simple body weight glute bridge exercises. Here you can see um, the level of activation of hamstring and glutes during the glute bridge. You can create a baseline level and individualize training according to the muscle activation level and look at the deviation during the season. Another important example, the last one that I want to show you, is the use of the EMG embody to assess return to play readiness after an ACL surgery reconstruction. One of the most useful tests that we have some interesting papers available is the use of the single leg vertical jump test to assess the rehabilitation process and assess the return to play readiness of a player by looking at the muscle activation of quadriceps and hamstrings into the injured leg compared to the non-injured leg. This is another type of testing that is going to be very, very game changing in a team setting and in a rehabilitation setting. Uh, in the next months, and we are going to go deeper into each of the testing that I showed you during this brief webinar, and we are going to go deeper into the neuromuscular profiling process by using the myotech embody. In the next webinars, I will show you how to practically create a neuromuscular profile for each player with the myotech embody in order to analyze training uh, training process and individualize training program based on of each individual neuromuscular profile of the players and athletes. Uh, Thank you very much for your attention, and to know more about Myotech technology and Myotech system, you can check for the Myotech website and look at the coming months, look forward for coming months to new webinars about new specific application of technology in